There's a special kind of magic that happens when you take a pile of inanimate objects, bits of plastic, some wires, a couple of motors, and you breathe life into them. That's what we're doing today. We're going to build a robot, not some far-off futuristic dream machine, but a simple, rugged, and wonderfully achievable little bot that you can build in a single weekend. Forget everything you think you know about robotics being too complex or too expensive. This project is about demystifying the process, about getting your hands dirty, and about that incredible moment when you flip a switch and something you built with your own two hands sparks into motion. It's a feeling like no other, and it's completely within your grasp. The goal is to learn by doing. This robot will be our classroom. Every great build begins with a well-organized workspace and the right components. It's what I call mise en place. Before we cut a single wire, we're going to lay out all our parts and tools, understand what each piece does and how it fits. For our weekend bot, we don't need anything exotic. Most parts are online or at a hobby shop. Let's start with the core components. Chassis, the robot's frame. 2 small DC motors, the yellow gearbox style, 2 wheels that fit the motor shafts, a caster wheel to keep it balanced. Next up, power and control, the heart and brain. Battery holder, 4 AA cells, an on-off switch. You could wire the motors directly to the switch, but that only goes forward. To unlock full movement, we need a motor driver. An L293D or similar H-bridge is perfect. It translates simple signals into the power to spin motors both ways. Grab a spool of red wire. Grab a spool of black wire. A solderless breadboard, small screws and nuts, hot glue and zip ties. Before we start the assembly, let's talk about the single most important rule in the workshop. Safety. It's not glamorous, but it ensures you'll be around to build again tomorrow. My shop has rules, and the first is simple. Wear your safety glasses from the moment you start cutting, drilling, or even just stripping a wire. A stray bit of plastic, a clipped wire. It only takes a split second. Your eyes are your most valuable tools. Protecting them is non-negotiable. We're using AA batteries. Very safe, but electricity deserves respect. Avoid short circuits. Positive to negative with a loose wire can cause heat, melted insulation, or leaks. Cover exposed connections with electrical tape and double-check your wiring. Hot tools are extremely hot. Use the stand, never leave them unattended, and work deliberately. Solder with ventilation and wash hands afterward. Keep your workspace clean and organized. Clutter, spills, and tangles invite accidents. Use trays for screws and nuts so they don't vanish or become hazards. A few smart precautions make building joyful, productive, and safe. Now, with the rules of the road established, let's start building. Section 4. The Build, Part 1. Assembling the skeleton. Alright, it's time for the fun to begin. Prepare the chassis. This is the foundation. Place both motors near the back. Orient the drive shafts out to the sides and align them parallel. Trace their outlines and mark the screw hole locations. A little planning saves headaches later. If you're using screws, first drill small pilot holes, then secure the motors with screws. Snug, not cracked. Or apply a generous bead of hot glue and press the motor firmly into place for about 30 seconds. Repeat for the second motor and check both are secure. A wobbly motor makes a wobbly robot. Most hobby motors have a D-shaped shaft. The wheels match that profile for a tight friction fit. Line up the flat sides. Press on firmly until fully seated. Spin them by hand. They should rotate freely without rubbing. If there's rubbing, nudge the motor position. Find the front center line. This is where the caster goes. Set it so the chassis sits level or slightly forward when all 3 wheels touch. Attach with small screws or a healthy dollop of hot glue. It should stand stable without rocking. Congratulations! You've built a rolling chassis. It's starting to look like a robot. The skeleton is built. Now it's time to add the organs. We'll start with the power source. Place the battery pack in the middle for a low center of gravity and secure it so it won't shift. Mount the switch along the chassis edge for easy reach. No flipping the robot every time. Set the breadboard between the motors and battery. Press the L293D into the breadboard, straddling the center gap. This is the muscle control. Connect battery red to motor power. VCC2 VS. Black to ground, high current path for the motors. Run motor A to out 1, out 2, and motor B to out 3, D out 4. Polarity can be swapped later if needed. Jumper logic VCC, VCC1 to the power row. Set in 1 and ion 3 to logic power. Ion 2 and ion 4 to ground to drive both motors the same way. Wire the battery red to the switch, then from switch to the breadboard power rail. Connect one thing at a time and keep wiring neat. It makes debugging easy. One step away from motion. The moment of truth. Powering up and troubleshooting. Before batteries go in, inspect. No loose or stray strands. Wheels spin freely. Red to power, black to ground. Ensure the switch is off. Insert 4 AAs observing polarity. Give it room to move. Take a breath and switch it on. Ideally, it springs to life and drives forward. Fantastic. Let it run a few seconds, then switch it off. If it does nothing, think power. Fresh batteries, correct orientation, switch wiring, and power ground continuity. If only one wheel spins, trace that motor's path to the driver. Swap channels to isolate motor versus driver. If it spins in place, reverse one motor by swapping the 2 wires on that driver output. If it drives backward, swap both motors' leads or invert the driver inputs. Every problem has a logical solution. Patiently track it down. Take a moment to look at what you've accomplished. You started with a box of parts and an idea, and brought it to life. This little bot is proof you can finish a technical project. Level up with a microcontroller like an Arduino, wire it to the motor driver, and write simple motion code. Program sequences, add a bump switch, light sensor, or IR line follower. Each sensor is a new sense. Try different wheels. 3D print a chassis, add a gripper or a speaker. Experiment boldly. Keep building. Stay curious. Welcome to the club. You're a maker now.